Okay, welcome back. It's been a week. I've just connected the cell to the data logger. Haven't ran the pumps or anything yet. 0.3 volts. It's been sitting there since the last discharge. So I'll give it another charge up today. Slightly longer, I think I can make it today, hopefully. So I'll connect the pumps. That'll run straight away as soon as I connect the power to the pump. And we'll take note of the voltage now, 0.329, and I'll get back when I connect it. Okay, pump started up straight away, started pumping fluid through the cell. No change in voltage. So I'll connect the charge and start charging. Okay, it's around about the same voltage setting on charge as the last run, but we're slightly down on milliamps. We're down to 400. We're normally up near 700 milliamps. As again, I think the pump's 32%, losing our little data numbers there. The threes are not. Ah, there we go. Yeah, we'll keep it at 32 is good. Alright, so I'll continue charging and I'll get back. Curve looks like it's dropping in. It's like it's charging better maybe. I'll keep an eye on it, see how it goes. Okay, we've been on charge now for 6 hours and 11 minutes. And for an hour I've had the pumps pumping while charging, and we're at 2.2 volts and 770 milliamps. So I'll set up the data logger to do a discharge and I'll get back. Okay, time to shut the cell down. It's been running for 5 hours and 30 minutes. It's currently at 0.1 volt and 281 milliamp hours and 113 milliwatt hours. So it's sort of declining, so I'll pull it apart when I get a chance and see what's going on the inside. I'll just see what happens when we shut the motors off. Okay, we've got a raise in voltage, we're still under load. Okay, seems to be working better when the liquid's not flowing. We're stabilized. Maybe the flow rate's a bit too fast. I'll leave it for a little bit longer and get back. Not long, about 5 minutes. Voltage seemed to go up to 0.33 and now it's slowly dropping without the pumps going, so we'll turn the pumps on and see what happens. Okay, we get a major drop. Data logger decided to make a noise. Okay, and our voltage is raising again. Oh well. I'll leave it at that and pull it down tomorrow maybe if the voltage isn't anything interesting. Okay, it's the next day. I haven't touched the cell until now. I'm going to do a crude test. I'm going to do a short circuit with this one, measuring the milliamps. and this one's on the voltage. It's currently at 0.63. I haven't got the motors on yet, so we're going to plug on the negative side, and then I'll come back and we'll connect a short circuit and run the pumps. The pumps will be running as soon as I connect the power. Okay, I connected the power source, turned off the speed controller so it pumped a little bit. Now we're at 0.6. Turning on the pump. Okay, voltage is going up. Connecting a short circuit. Okay, we're at 70 milliamps and dropping. Millivolts now. And that tank, the negative one's gone a different colour, and the positive is darker. We need some sort of gas diffusion item because of the halogens. They have to be diffused back into the liquids apparently for zinc bromide cell. So I've discovered that. So that's why they sort of so condensed, I reckon. Might help having the tubes now submerged in the liquid. They can sort of diffuse through the liquid maybe. So we're at 30 milliamps on a short circuit and microvolts. So I'll keep running that for a while, just to sort of convert some of that liquid back, I guess. And also maybe deplate the negative side of the zinc. I'm going to pull it apart later, not today but some other day. I'll put that on this video, so we'll keep it short. Okay, it's been 10 minutes, so I decided to turn the speed setting down to 20%, and we got an increase in milliamps. Now it's been holding for about 5 minutes at that, but we're only 0.64 millivolts. And if I increase the pump, okay, we're at 66%. We sort of went up a little bit, and now we're dropping in milliamps again. Sort of all over the show. I'll turn it back down to 20%. That's at 24%. Oh, we got an increase in voltage at 24%. And also milliamps. It'll go down a little bit more. Like that. So I'm at 27%. So 24% looks like the sweet spot. Going by these figures. Okay, it's been 45 minutes on a direct short circuit. That's 001.5 millivolts, and I'll just connect it to the multimeter and we're bouncing up. Okay, we're still drawing 44, maybe 42 milliamps. Not 44 it's going to sit at, and 0.06 volts. So I'm wrapping it up, so the next time you'll see it, it will be pulled down and we'll see what the plates look like and clean it up and get ready for another test with some carbon pad felts. Okay, back with the teardown of the cell. It's been about a week and a half maybe since it was last run. I'd imagine what happened here was these were supposed to be 316 screws. The head's dissolved, so that probably dissolved in the first charge of the cell, so the carbon plate may be just floating around in there. That was the side what was facing up, and the side what was facing the carbon, you can see heavy pitted damage to the 316 stainless plate on both of them, where the electrolyte must have been flowing through. That carbon pad was the positive side, which is intact. Oh, it was intact. So they had a stainless steel mesh, which was supposed to be 316, but as you can see the colour of the rust, I would imagine it wasn't. It came from China on eBay. So it totally destroys that. And we got some pitting in the main plate on the positive side, 316 as well. This is a better grade stainless. And pits are pretty deep, so the plate would have only been doing the work, I'd imagine, and not the carbon pad. So that's probably why it was only doing 50 milliamps. So it's sort of somewhat held up the better quality stainless. That's what these things are made out of too. The membrane survived. That's the zinc side. As you can see, the zinc build-ups. The cellulose acetate held, and the cotton fibre held as well. The coating of silicon for the gasket was done a bit better. I applied the silicon, put the cell together, and sort of just lightly pressed it, and then waited for it to dry a bit better, and then squashed it together. The zinc side, the negative plate, that's held up. Nothing's been corroded in the stainless steel side, except for that rusting of that metal. We've had some zinc build up there, and mainly a lot of it on the stainless itself. It's quite thick on the stainless. So we'll have to come up with some other idea to fasten these things, or perhaps screws again, but coat the screws in silicon. Where the silicon is, there's no corrosion, that's stuck pretty well. So I'm guessing silicon will protect it. It's actually pretty firm on there. I'll have to scrape that off later and think about what to do with these now that they're knackered. So overall, it sort of worked. The tubes here came out of a laser printer. That were those rollers right there. So it's either 316 of good quality. Magnet doesn't stick to it, so I'd imagine it is 316. They were like the perfect size, so I just chopped a few of them off to make those little tubes in there. we could probably forego this housing around the membrane and stick it straight to this, which will lessen the distance between the plates. So that was quite interesting how it just dissolved those heads off. That probably happened in the first charge, I'd imagine, or second charge, one of thereabouts. But I didn't notice any difference in milliamp draw from the cell. So carbon pad may not have been touching properly, or it's not a great carbon pad anyway. That carbon wasn't that great. So there you go. I've collected all the electrolyte and stored it. I've mixed it into one container anyway. Screws are a bit rusted, like where there was probably some leakage. They are just galvanized steel screws and bolts. So not too bad for a first attempt. Happy with the membrane and the cellulose acetate not being eaten away by the corrosive nature of the zinc bromide. That must be some sort of zinc compound. That was the negative side, is it? Or is it not? Hang on. Now that's the negative side, so zinc does get through or something. Sort of brownish looking. Probably won't use this membrane again. I'll make a fresh one. The electrolyte didn't get to the perspex this time, by the looks of it, but I'll have to scrape it off and find out for sure. Can't see any cracking going on in there. So if you seal it up properly, maybe a bead of silicone around the inside edge, which I didn't do. I should have. Would have helped better. So we got some brown looking gear. Alright, so that's it for the flow cell for a while. I'll address those issues. Probably still use this plate and just clean it up, even though it's sort of pitted. The next cell I'll make will be using carbon felt as these pads, and with the zinc hexacyanoferrate on this side, maybe that will help. Never know until you try these things. The pumps and all that still work. I gave them a flush out with some fresh water to clean them. The one-way valves are held up with where they were sitting. They sort of got discoloured, so we probably formed aluminium bromide on the outside and zinc plating. And that's the other one. But they actually work pretty well. Windscreen wiper pumps, they actually run for 8 hours easy without any hassle. So I'll finish cleaning up, and thanks for watching.